Okay, here we go. So we are on the last section of chapter 4. Remember on Monday we talked about quadratic equations, so make sure that you're practicing those. Just remember that formula works for anything, and it will tell you the solutions to the equations, both real and in the complex realm. Give me 1 second. I'm just going to look something up. Quadratic solver Desmos. Yeah, so Desmos does not have necessarily a quadratic formula solver built in, but if you do have your TI, there is a way to put that into your calculator to program that in. All right, so I think we covered that. I think everyone felt pretty comfortable about it. If you have any questions, let me know. The last section that we're going to do today is actually graph and solve quadratic inequalities. Okay, so what I want to do first is go way back to the beginning, way back to 4.1, where we were actually graphing just regular quadratic functions. And actually, we can use graphing to solve quadratic functions. So let me just pick one here. So for example, way back in 4.3, we had r squared plus 2r equals 80. So I just want to, again, remind you that one possible way to solve these kinds of equations is by graphing. So if you have Desmos or your TI, this is what you're going to do. So our equation was r squared plus 2r equals 80. Neither calculator actually really responds well to r. You have to always change your variables to x. So if you wanted to graph this and solve it, one side of the equation, the left-hand side of the equation, is going to be y equals x squared plus 2x. This is the left-hand side of my equation, okay? And the right hand of my equation is going to be y equals 80. So you would plug this in either way, right? Either if you're using Desmos or if you're using a TI calculator, you're going to have a y equals. You're going to have two y equals. And the place where both of those are true is where they intersect each other. Now, since I know this is y equals 80, I know I'm going to have to zoom way out to find y equals 80 way up here. And this point right here is when x equals 8, y equals 80. It's true for both of these. And when x equals negative 10, y equals 80. So my two solutions to this equation are x equals 8 and x equals negative 10. Okay, so that's kind of in the way back what we talked about. And we talked about that on Monday as well. But I just wanted to make sure everyone saw that. So now that we skip to now that we get to the last section, which is the same idea, except now we're going to put inequalities in with our graphs. So this is mostly just a practice in putting it into your calculator and then understanding what the result is. So the important thing is understanding. So the first thing that we want to graph is y is less than negative x squared. Okay, so this is where Desmos does a little bit better job. So sometimes the TI definitely wins with your matrices. The Desmos definitely wins with graphing inequalities because it will actually recognize that this is inequality. If you're using your TI calculator, you're going to have to graph y equals negative x squared. And then you're going to have to figure out which side of the graph should be shaded. Okay, so we'll just zoom back in here a little bit. So a TI, you're going to have to do this. Desmos is a little bit better of understanding what an inequality looks like and shading it for you. So it kind of wins on that one. Okay, so what you'll notice is that if I just graph y equals negative x squared, you could do this in either type of calculator, and it will show you a graph of your parabola, right? But we know that y is less than negative x squared. So I need to figure out what to shade in, right? I need to figure out where I should shade into my picture here. So if I was using my TI, like for example, if I was on standardized test or whatever, if I was using my TI, how would I figure out what to shade in? So this is what I have, right? But I know that y actually has to be less than negative x squared. So just like in a number line, right? When you're graphing a number and you have the less than or greater than sign without the equal, we use an open circle. When we are graphing and we have an inequality without the equal part, we used a dashed line to represent it. So the first thing I know is that this is going to be a dashed line. If I can have my pen right here, let me see if my pen will work a little better. So I know this is going to be a dashed line. It still goes along here. Now I have to figure out which side is going to be shaded. So what I do to figure out what side is going to be shaded is I pick a point that's on one or the other of the sides. So for example, if I pick right here, this point right here, okay, that's x equals 1, y equals 1. And I need to see if that's true. Okay, so when y is 1, is that less than negative, or yeah, is that less than negative 1 squared? Well, this is just like 1 is less than negative 1. Is this true? That's not true, right? So that means that this part is not going to be shaded. So that means the opposite side is what's going to get shaded in. Okay. So then, as I said, Desmos does a little bit better job of this. This actually knows when I type it in, it gives me the dashed line and it is able to tell me which side to shade in. But I just want you guys to understand how did Desmos come up with which side to shade in. And that's just by basically seeing which points are valid in your inequality. Okay, yes, but wouldn't it be negative? Yeah, so Anton, that one was a little bit weird, right? Because, sorry, I just saw your comment. So the way this is written, if they wanted the negative sign to be part of the squared, they would have had to write it like, or if mathematicians, it would have been written as negative x squared. And then when you square it, you would have gotten rid of the negative 1. But since the negative is outside of that square root, yep. Yeah, I know. I almost explained that, Anton, because I was like, this one's kind of a little weird like that. But yeah, good question. All right. Does that make sense? Yep. All right. Aaliyah says yes. Everybody else good?
Yeah.
All right. I'm going to assume you guys are good, but let me know if you have any questions, okay? All right. So we have some other ones to graph. Again, it's not a difficult section to do because you're plugging it in. I just want to make sure that you guys understand what it means because that's really the important part, right? So number 2 is y is greater than negative 2x squared plus 9x minus 4. Okay, so this is a case where we have our parabola, right? The parabola, again, is dotted line because this is y is greater than. It does not greater than equal to, okay? And then the part that is true for this is the outside parts that's shaded. Now, if I was using my TI and I needed to check this really quick, I would actually pick this point right here. I would pick 0, 0. So if you put 0 in here, out, TI can help you out. Just understand why you're getting what you are. Let me just show you on here. If I made this greater than or equal to, so now you see that I have a solid line. And just a reminder, the dotted line means that if I have a point on this line, so if it was this, just that, the dotted line, okay, and it looks like, that's okay, Olivia, thanks for joining. We're just doing the last section, 4.9. So for example, one of the points on my dotted line is 2.25 and 6.125, right? 2.25. So if I have a dotted line, that means if this point is on that dotted line, that means it's not true for my equation, right? If I plug it in, I'm basically going to get that they're equal to each other, and that's not true. If my inequality, again, was this, greater than or equal to, then 2.25 would be a valid term. So that's why you get the solid line means everything on the line is true. The dotted line means everything on the line is not true. It's just the barrier to all the true values. Just kind of a good review of all the different graphing that we've done so far. Okay. So number 3 and 4 are actually a system of equations. So let's see what this looks like. We have y is greater than or equal to 2x squared. Okay. And then we have that y is less than negative x squared plus 1. So I'm doing number 3 here. Nope, not V. Okay, so there's my two graphs, and you notice it says and, so this is a system. So if I were to graph the two of these together, okay, it's actually going to be the places where they overlap. Do you guys remember doing this in chapter 3? It's the same idea of what we were doing in chapter 3 with linear equations, but now we have quadratic equations. Yay. So if I were to graph this where both were true, my graph would look kind of crazy, but it would look like this and this part shaded. Okay. So if I asked you, is point over here, is point 1, 1, is that a point that is valid for both of my parabolas? No, right? 1, 1 is not a valid point. So this one is not, because it's not in either one, right? What about down here at 0, 0? Is that true for both of my parabolas? So 0, 0 is true for both of my parabolas, right? It's on the solid line down here, and it works in both of my equations. If I put in 0, 0 to both of these, then that's true for both. So this, yes, this is a valid point on both of mine. Okay, if I picked a point in here which looks like there's a point right in here, let's just say that's 0 and 1/2. Is that valid for both of my inequalities? Yep, that's valid for both my inequalities. It's right in the middle, right? And then one more would be up here at x equals 0, y equals 1. Is that point valid for both of my inequalities? Sorry. So 0, 1 is not valid for both of them because 0, 1 is on this dotted line. So it's okay for this one, right? If I put in 0, 1, it would work. If you put it in here, when y equals 1, x equals 0 squared plus 1. So 1 is not less than 1. It would have to be a less than or equal, which it's not. So 0, 1 is not valid. Okay? So again, graphing it is not the hard part. The understanding it is the part that we got to make sure that you guys do understand. So far, does that make sense? All right. Olivia says yes. I'm going to assume everybody's doing good. Okay. Last two, 5 and 6, solve by graphing. So this is why I started off with a call with, you know, how do we solve quadratic equations? Well, how do we solve quadratic inequalities? Okay, so what you're going to have to do, let's just see. Desmos actually might be okay with this. Let's see. Let's do number 5. I can't actually remember. 8x or x squared plus 8x. That's not right. Somehow I got that. Plus 8x is less than or equal to -7. Nope, it doesn't know how to graph that. So let's just type this in as the two sides of the equation. That's what I thought we needed to do. So one's going to be y equals x squared plus 8x, and the other side is going to be y equals -7. Okay, and I think I need to zoom out a little bit. Here we go. All right, so x squared plus 8x is the parabola here on the left-hand side, or my green equation, sorry, my green thing, and it's less than or equal to -7. Okay, so what are my values of my parabola that make this true? All right, so for example, my parabola is right here at 0, 0. So this takes a little bit of work. You got to kind of figure it out. Let me take a screenshot of all this, and then I can kind of write on here. Okay, here we go. So this is my original equation right here, right? This is my graph when I put them together, but I need to figure out because not all of this graph is true, right? For my left-hand side of the equation, x squared plus 8x, one of the points on that equation is 0, 0. So I need to figure out when I put in 0, 0 to this equation, is that true? So is x squared plus 8x less than or equal to -7? So if I put in x equals 0, I get 0 is less than or equal to -7. So this is not true, right? Not true. So I have this point up here is not part of my solution. All right. If I go down here to this point, it looks like it's at 2, 4. Looks like it's at negative 4, 16. I'm going to verify by going back to Desmos. Yeah, negative 4, 16. Negative 16, sorry. Okay, so is this point, let's do this in another color, is this point valid when it comes to my inequality? So remember, my inequality is x squared plus 8x is less than or equal to negative 7. So what happens when x equals negative 4? Is that true? So I get negative 4 squared plus 8 times negative 4. Is that less than or equal to negative 7? So it's 16 plus negative 32 is less than or equal to negative 7. And if I add those two together, I get, what do I get here? Negative 4, 6, yeah. Negative 16 is less than negative 7. So this point down here is true. All right. So all the values of x that make this true are the values that are along this line here. Okay. From this point here to this point here, and these two are true because I have this negative sign. So I need to figure out what these 2 points are, and that'll tell me what are all the values of x that are true. Okay, so if I go back here to my Desmos, right? Somewhere's Desmos. There you are, Desmos. Maybe. Oh, here it is. Okay. So between x equals negative 1 and x equals negative 7, those are all the values that are true for this equation. So if I wanted to know what all my values of x are, I know this is a crazy mess on my screen. X has to be greater than negative 7 and less than negative 1. Those are the values that are here and here. It also can be equal to each of those values. That makes each of those true. So this is when x equals negative 7, and when this is when x equals negative 1. So these are all the values of x that are true in between those two. Okay, did that make sense, or did I lose you guys on that one? Think so. It might be something you guys wouldn't try, and then when you try it, if you have questions, let me know, because sometimes when you're working on it. All right. I got another, yep, it makes sense. All right. So that's kind of the most complicated you're going to get. You're going to have to solve it. Other ways. You know what? Let's do one from, let me look at your homework problems here. 35 through 43. Odd. Let's do one from your homework. And then then we'll wrap up chapter 4. Okay, so let's do number 43 from your homework. Okay, so 35 through 43 says solve the inequality by graphing. So if you don't have your book, it's okay. I'll pull it up on, or I'm going to do it on here. get back to Desmos. Okay. So number 43 says 4x squared minus 10x minus 7 is less than 10. Less than 10. Okay, so if I'm going to write this out, here, we'll get all our points up there, and I will pull it up in Paint, and then we should be able to do this one. So this is number 43 from your homework. Okay, there we go. All right, so the actual equation in the book says number 43 is 4x squared minus 10x minus 7 is less than 10. So basically, I need to figure out which values of x are true for my for this inequality to be true. So my tip is to always start with the easiest one possible, which for me, I think, is this point right here. Okay, because this is when x equals 0, y equals 10. And so I need to figure out, am I going to shade in the inside part in between these two numbers, or am I going to shade in the outside part? So when x equals 0, what happens to my inequality? Well, this is 0 minus 7 is less than 10. So is that true? Is negative 7 less than 10? Yeah, that's true, right? So that's good. So that means that everything inside, in between these two numbers, all those x's are true. Okay. And then I have to figure out, these are my two endpoints. My endpoints are at negative 1.161 and at 3.3 or 3.661. Okay. Are those two true? Well, because I see that my inequality doesn't have a less than or equal to sign, then that means that this point is an open circle and an open circle. So if I were going to write my solution, I know that x is greater than negative 1.16, right? And it's less than 3.661, but it can't actually be either of those two values. So you don't want to put the less than or equal or greater than equal to sign on those. Okay. Does that make sense? A little more concise? Not too bad to do. Cool. Okay, so that is the end of chapter 4. Again, your chapter 4 homework is due on Monday. Your chapter 4 test is going to be due the following Monday. I'll send it out after class today. There's a couple people that are going to stay after. We're going to talk about a couple things on the chapter 3 test. So if you are not one of those people, you're feel free to go ahead and go. And yeah, have a great rest of your week. Thanks for coming. Okay. Let me close this. Leave that open. All right. All right. So what I wanted to chat with you guys about, I think all three of you, for the matrix part of the test, I think either had forgotten or didn't do those sections. So my biggest thing with algebra 2 is I want to make sure that you're understanding all the concepts and that we get it all, and that especially on tests, you're always able to at least try something. Yeah, how to do that. So I think all of you had written it, either left it blank or said, I forget how to do this, or whatever it might be. So what I want to do is since we have this opportunity, is explain it one more time and give you guys the opportunity to redo those 3 test questions, because I can't give you any points if there's, you didn't know how to start. And I don't like to see that. I don't like to see blank papers. So if you guys spend a couple minutes with me here, I can re-explain how to do that part of the test, and then you're welcome to retry it and turn it in for more credit on Monday. So help if I pull up the test, right? Chapter 3 test, this one. Okay, so what I'm talking about on the test is these 3 guys here. Use a matrix to solve the equations, and I realize it's weird, number 1, 2, and 3 at the end of the test, but I just want to go over how to do this again, because it's actually not too difficult to do, and it's something that you can do in higher level math pretty easily. And like I said, I saw everybody kind of had it blank, so maybe going through it one more time will help you understand it. Okay, so what this is, sorry, I'm trying to get up okay, so what we're going to do is we're going to use matrices to solve these kinds of equations. Okay, and so it sounds really intimidating, but it's really not bad at all. So what I want to do is actually, I'm just getting a different example, because I don't want to do one that's on your test, but I want to do that one that's really, really similar to your test. Okay, so it's the same idea, but just different numbers. Okay, so if I have these 2 systems of equations, I have 3x plus 2y equals -1 or -11, sorry, make sure I write it right. And I have 4x minus 3y equals 8. Okay, that's a 2 here. And I want to solve these using a matrix. So the first thing that you have to do is you have to put these into a matrix, which sounds complicated, but it's not. So really what you're going to do is you're going to put the coefficients in a matrix, and you're going to multiply it by some x and y. And what I mean by the coefficients is you're going to look at the numbers that are out in front of your x and your y. So we have a 3, a 2, a 4, and a -3. So notice here, this is a negative number, so that actually, or it's a subtract 3y, so that negative comes with the 3. Okay, and then that equals -11/8. Okay, so does that look kind of familiar? We can rewrite our equations as matrices, right? Or now that you're seeing it again, you're like, oh yeah,
that
I remember
looks
seeing
more
that.
familiar now. Yeah.
All right, I'm gonna keep going, but if you guys are confused, please tell me. And I'm happy to do it, okay? Looks familiar, all right. So then, Now that you see it, you're like, oh yeah, I remember doing that, right? So then what we want to do is we want to solve this. So this is where it's going to get a little theoretical for a minute, and then it's going to come back to reality, and you're going to say, oh, that was super easy. Okay, so we're going to call this matrix A, and we're going to call this guy matrix X, and we're going to call this guy matrix B. It's like we're kind of taking the whole big matrix and we're making it very generic. Okay, so back a long, long time ago, if you have A times X equals B and you wanted to solve for X, you would, well, divide both sides by A or multiply both sides by the inverse, right? And then you would solve for X. So in order to solve a matrix equation, what we're going to do is we're going to say A times the inverse of A, which basically undoes it, just like over here. A times the inverse of A, that just makes it 1, right? Times X equals the inverse of A times B. Right? It's just like we solved the equation over here, but we're doing it on a much bigger level of a matrix. So A times the inverse of A just gives you 1, just like A times the inverse of A over here gives you 1. So what this tells us is that X equals the inverse of A times B. Okay, and now you're thinking in your head, all right, great, Mrs. Ross, you just told me this, but how in the world do I solve it? Here's how your matrix tools come into play. Okay, so what we can do is we can plug in matrix A and matrix B into either our matrix calculator or our TI calculator. So I think all of you guys have access to TIs, and I know we practice in class how to put it in. I don't have an online TI, so I'm going to have to go with Desmos for this, but you can also totally use your TI. Actually, TIs are better at matrices. But since I can't do that here, I'm going to show you what that means. So in Desmos, let me move this over here. Or in your TI, what you're going to do is you're going to not make it big to take up your whole page. You're going to put in these two matrices that you started, the original ones. You're going to put in A and B. Okay, so we're going to make a new matrix. A is a 2 by 2 matrix. Okay, you see A is a 2 by 2, so it's 3, 2, 4, and -3. Okay, so that's your first matrix. B is over here. B is a 2 by 1 matrix. So we want to put a new matrix in, and it's a 2 by 1 matrix. Okay, and B is -11 and 8. So now we've told Desmos or we've told our TI what our two matrices are. So now it knows what they are. Okay, so now to solve it every single time, what you want to do to find your X and your Y is you want to take the inverse of A times B. So what that looks like here is you take A and you want to do the inverse, and then you want to multiply it by B. Okay, then your calculator does all the work, and it tells you that the answer is -1, -4. -1, -4. Okay, so it tells you that X, matrix X equals -1, -4. So what do you think those two values are? Look way back up here where matrix X is your X and your Y. So that means that the answer to this equation is -1, -4. So all the way back up to the top. When we had this set of equations, the solution is -1, -4. Okay, so matrices are just basically a nice, easy way to, once you understand them, they're an easy way to help you solve these big linear equations, especially if you go back to your test and you look here and you have 3 equations and 3 variables. It's the same thing. You set it up the same way, and you're still going to take the inverse of matrix A times B, and that's going to help you, or that's going to solve the equation for you, not help you. It will solve the equation for you. Okay, so now that I showed you that, does that look familiar? Does that jog everybody's memory? Yeah, oh yeah, I saw it. Auto, yeah, those are your X and your Ys, right? Cool. So who would like to see another example, or do you guys feel confident that you can try those 3 on the test again? Okay. Anton, you feel good? One more? Sure. Sure. Okay. I will do one more. But if you feel like you're good and you want to go try it, that's fine too. All right. So, let me just get another one. Sure. Thanks, guys, for staying. And yeah, if you want to turn those updates in on Monday, I can update your grade. Bye. Have a good week. Okay, so let me do one more, just to kind of make sure it's full circle. Yeah, Anton, turn that in on Monday for those, and I'll update your grade. Okay. Okay. All right, so here's another system of equations. If we want to solve it using a matrix, what we have to do is we have to rewrite this as a matrix. So the matrix would look like this. It would be 3, that's the number in front of X, 1, -1, because there's a negative in front of X, and 2. And that's multiplied by X and Y. And that equals -1, 12. Okay, so now I don't have to kind of go through all that whole explanation again. I know that if I can basically multiply, if this is A and this is B and this is X, right? A times X equals B. I can rewrite this as X, like if I take the inverse of both sides. Okay, X is just equal to the inverse of A times B. Every time, inverse of A times B. But now what I have to do when I go to my, whatever my matrix tool is, I need to change my A and my B. Okay, so for this particular one, A is going to now be 3, 1, -1, 2, right? That's my new A. And B is -1 and 12. Okay. And then I already actually have still typed in there the inverse of A times B. And so the inverse of A times B is -2, 5. Okay, so that means that the answer to this equation is -2, 5. That's your X and your Y. Okay. Good. So basically for all three, you're going to do the same thing. The third one, I don't have it up on my screen. The third problem, wherever it's at, there's 3 of them. So your matrix is going to be this one. Instead of a 2 by 2, it's going to be a 3 by 3. So you're just going to make it bigger. And you can even call this A if you want to. You can go back up here and do that. Yep. But same idea. So, all right. Thanks for staying on. I hope you have a good rest of your day. Sure. Glad to do it. Thanks. Talk to you later.